Sorry for inconvenience. There's a internet issue. So, as I told, so electricity is the property is observed around 600 years back, 600 BC. So 600 BC, that is around 2624 years ago, by a great Greek philosopher Thales. Right? Thales is the name of the scientist who for the first time observed. Where he observed? He observed between the two bodies. One is amber, second one is fur. So already I told amber is nothing but a blue colored stone. When this blue colored stone is rubbed with the fur, animal hair, when both are rubbed, both the bodies are acquiring the charges. Right? The word charge is introduced there only. Charge. When two bodies are rubbed with each other, there is a transfer of electron takes place. So that you come across in chemistry. When there is a transfer of electron takes place, a body which donates the electron will get the positive charge. A body which accepts the electron get negative charge. Like that, when amber get positive charge and fur get negative charge. So they both are attracting each other. Like your comb. When you are combing your hair, you see some hair is attracted to the comb because when you are rubbing like this, the charge produced between the comb and the hair. Right? That is called the word. Because why they named the word means this amber is there, the amber, one kind of stone. In Greek letter, it is called as electron. In Greek, E-L-E-C-K. In Greek, amber they used to call as electron. That is the reason, as the charge is absorbed from the amber, the word is named as electricity. So, electricity is the word derived from a Greek letter, electron, by Thales. Right? So, not stopped here. So many, for example, use the glass rod with silk cloth. Right? When the glass rod rubbed with the silk cloth, right? And suppose cat skin, he took the cat skin and rubbed with the ebonite rod, one kind of rod, ebonite rod. So many things they are done, so many things rubbed with each other, and they found that in such cases, both the bodies are getting the opposite charges, right? Opposite charges, not like charges. So from that, they derived the word electricity. That is the word introduction is made around 600 BC. Now we are 2024 AD. Right? So overall 2600, around 2000 years back, this property is observed. But so many years, the studies are not done. So this not came out that time. Later, slowly, a scientist called Gilbert, right, Ampere, Faraday, in around 600 years, 680, the development is done. Till then, there is no much observation on the electricity. But later in 680, slowly one scientist used to study about this phenomena that is called frictional electricity, that is called. Because electricity produced by rubbing of two bodies. That frictional electricity laterally slowly developed, and what we are enjoying now, electricity. Right? Either tube light, bulb, fan, AC, how they are all moving, what is transformers. All these are the electrical devices. So what we are observing is, there is a development. From 600 BC to till the date, there is a lot of development is done in the electricity, and lot of requirement also there. So that time they used to live without electricity only. But nowadays we cannot even imagine also. Imagine to live without electricity. Right? So that much importance is there for this electricity history. So when you move forward, enter into our topic now. So what we are going to discuss in this chapter. So we have only two synopses for the next exam. So first we'll discuss about what is electric charge. I told, when the two bodies are rubbed, both of them are getting the charge. Then we'll discuss about what is conductors, insulators, and others also there. Then Coulomb's law is there, an important law. Then surface of electric current, then electric circuit. So these are the 5 topics we have to discuss here. Later, some many are there. We can go discuss 7th, 8th, 9th, 10th classes. But only for 6th standard, we discuss only about these 5 topics. Right? So first we'll see introduction. What is electric charge? So I already told simple logic. When the two bodies are rubbed, with each other, for example, we've taken one body here, one body here, right? This is say some rod, metallic rod, and this is some cloth. So everyone is having the positive negatives. Charges will be there in every body. When both are rubbed, what happens? There's transfer of electrons takes place. So electrons transfer from one body to another body, either 1 or 2 or whatever it may be. Due to transfer of electrons, what happens? Both of bodies get the opposite charges. When they gain opposite charges, they start attracting, because as per the electricity, like charges repulse, just like a magnetism only. Like charges repulse and unlike charges attracts. Unlike charges attracts. This observation made. This is also called law of electricity. Okay, law of electricity. So charge is nothing but this one. The body which is donating electron will get the positive charge. The body which is accepting electron will get the negative charge. That's all. Only there are 2 charges are there. That we'll see here. A comb attracts bit of paper after being rubbed with the dry hair. Suppose your dry hair is there, comb your hair. After combing, bring that comb near to the small papers. It will attract the papers because of the charge. The cracking sound made by the nylon or terylene socks when they take off from our body. When you are wearing the socks of different quality, nylon is one kind of cloth, variety like silk. So there is some sound when you are removing from your legs. That is because of the electricity. Or some examples, phenomena observed in our daily life. These phenomena are studied under the topic called electrostatics in physics. That is called electrostatics. So there are 2 types of electricity are there. One is electrostatics, also called static electricity. And second one is current electricity. When charge is at rest, study about the charge at rest is called static electricity or electrostatics. Study about charge in motion is called current electricity. There are 2 types of, we'll come across in higher classes. Okay. Now we start. What is electric charge? Electrostatic is the study of static electric charges. In nature, there are 2 types of charges. One is positive charge, second one is negative charge. Clear? There are only 2 charges only. So what is charge seeking? Every substance is made up of atoms containing equal number of positive and negative charges. That is called neutral body. Every body is generally neutral. Why? Because it contains same number of positive and same number of negative. Okay. A positive charged body has some positive charges and negative charged body has negative charges. Have more negative charges. So what is my positive charged body? It has more positive charges compared to negative. If 5 negative are there, 6 positive maybe. Or 7 positive. Whereas negative charged body means it contains more negative charges. Electric charges can be excited independently either as positive or negative charges. The SI unit of electric charge is Coulomb. So Coulomb is the name of the scientist, right? Coulomb is the unit for electric charge, which is denoted by letter C. Right? Clear? So try to understand, when every body contains equal number of positive and negative charges. No doubt in that. Whatever body you take. So that's why they are called neutral bodies. But whenever a body contains more positive charges, it is called positively charged body. Which contains more negative charges is called negatively charged body. We can get separate positive and negative charged bodies, which is not possible in case of magnetism. Right? We can get both separately. Okay. So that is given. This particular charges, either negative or positive charge, is measured in units called Coulomb. Coulomb is the name of the scientist again. So electric charge, whether it is a positive or negative, measuring the units called coulomb. Right? Okay. Up to here, clear. Next, all the materials. There are so many materials in and around us. You take some stone, you take some iron piece, you can take some gold, you can take some silver, you can take some rubber. So many are there. So try to introduce them in the electric field. So how they are influenced? Based on the behavior, all the substances are classified into, see, one is conductors. So all the electric substances you can call all substances available. All the substances are classified into actually three categories. One is conductors. Second one is insulators. Third one is semiconductors. So based on their behavior, if you remember, we read in light also. In light chapter, what we read? Transparent, translucent, and opaque bodies. Similarly, here also, the substances which allows the light to pass through them, electricity to pass through them, are called conductors. All the metals will come as conductors. Metals and their alloys, that's mixture of metals, allows the electricity to pass through them completely. But there are some substances which does not allow the light to pass through them. They does not allow, like wood, rubber. They does not allow light to pass through them. They are called insulators, which completely stop the current. But there are some more substances are there which partially allows the current. Partially, means slightly. They are called semiconductors. That we'll discuss in higher classes. The very, very important part. So all the substances based on behavior in electric field are classified into conductors, insulators, and semiconductor. That we'll see here. Right? See, the first one is conductors. The substances which allow electricity to pass through them are known as conductors. Example, metals, human body, graphite. In graphite, you know, matchstick. Over the matchstick, whatever is there, that is called graphite. It is also a good conductor of electricity. Human body will also conduct electricity. That's why it gets shock. Okay. Earth is a good conductor of electricity. Earth is a big conductor. In conductors, there are free electrons and they are responsible for the conduction of electricity in a conductor. Why they are conducting? Because they contain some free electrons. When free electron flows, due to flow of electrons, electricity will come. Got it or not? Why they are conducting? Because there are free electrons in the conductors, like metals or human body or graphite, many more are there. So conductors are the substances which allow the electricity to pass through them due to presence of free electrons. Examples, metals, human body, and graphite. Right? That is the one category. The second one is insulators or dielectrics or non-conductors, anything you will call. Substances which do not allow the free electrons of charge through them are called insulators. Plastic, diamond, wax, sealing wax, and wood. We'll use wax for sealing, na? Red color. They does not allow electricity because they does not have free electrons. So substances which do not allow electricity to pass through them are called insulators, like plastic, rubber, diamond. Diamond also very strong, very strongly bound carbon atoms are there. So it does not allow current. Right? So this is a category of the electrical substances. So we learn about the two things today. So history we have seen anyway. The history of electricity, which is very old history, 2500 years plus. The word electricity is introduced by Thales, the Greek scientist. And he observed that when the two bodies are rubbed with each other, both the bodies acquires opposite charges by transfer of electrons. Because of that, they attract each other. Right? And then he introduced that there are two types of charges. One is positive charge, other is negative charge. So generally, every body is neutral. But due to rubbing, they are transferring electrons and getting the more positive charges or negative charges. The substance having more positive charges is a positive charged body, Having more negative charge is the negatively charged body. So these, all the substances in and around us, they are classified based on the conductivity of electricity. The substances which are completely arouse electricity are called conductors, like metals, human body, graphite, because of the presence of free electrons. But whereas insulators are those which does not allow the electricity to pass through them, because they doesn't have any free electrons, right? So here examples are given for that. So insulators, there are no free electrons. When the insulators are kept in electric field, it remains as an insulator when a certain limit of the strength of the electric strike. Beyond that limit, electric field becomes conductor. So up to certain limit, they may not allow. But to pass the more and more current, they may convert into conductor, right? Then third category, semiconductor. Semi means partial, right? Partially connect substances which allow charge partially, partly is called semiconductor, right? So examples come across silicon, germanium, and etc. In periodic table, if you know periodic table, in that fourth group elements, all comes under the category. So this is semiconductors. There is a separate branch is there in physics called electronics. Electronics is nothing but what you are seeing, the TV and all, computers, TVs are electronics only. They are completely made up of semiconductors. So before going for the next topic, let me show you one video on this basics of electricity. Then we'll move to the further topic if time permits, right? Just keep watching the video on basics of electricity.
Hello friends, what do we need to run our television set, refrigerator, DVD players, video games, computer and fax machines? Yes, it is electricity. Electricity has always been around because it naturally exists. Lightning, for instance, is simply a flow of electrons between the ground and the clouds. Objectives. At the end of this lesson, you will be able to define electricity, establish the relation between electric current and charges, identify the two types of electricity, define conductors and insulators. How do you study in the late evening? Of course, you light up your room using an electric bulb. Have you ever wondered what causes the bulb or the tube to light up? They need electricity to light up. Electricity passes through the wires and reaches the filament of the bulb, heating it up to glow. When we comb our hair with a plastic comb and take it near the small pieces of paper, the paper pieces are attracted toward the comb.
This you can do the experiment.
We then say that the comb is charged with electricity. This was first noticed by a Greek man named Thales over 2,500 years ago. Thales found that amber attracted tiny feathers after it was rubbed with silk cloth. This was due to static electricity. The origin of the word electricity comes from the term electron. Let us perform an activity to understand positive and negative charges. Take an ebonite rod and rub it with a piece of woolen cloth. Now suspend the rod by tying a thread through its middle. Now charge another ebonite rod in the same way and bring it close to the suspended rod. What do you notice? The suspended rod moves away from the second one.
Repulsion.
Now take a glass rod and rub it with a silk cloth.
Attraction.
Bring this glass rod close to the charged suspended ebonite rod. What do you observe now? The suspended ebonite rod comes closer to the glass rod. The charges produced in the ebonite and the glass is different in nature. These two kinds of charges are called positive and negative charges. The positive charge is shown by the plus sign and the negative by the minus sign. Merely as a convention, charge on a glass rod rubbed with silk is taken as positive, and that of ebonite rod rubbed with woolen cloth is taken as negative. From the earlier activity we can conclude that like charges repel each other and unlike charges attract each other. Fill in the blanks. We have just studied about electric charges and the forces they exert on one another. We have learnt there are two types of charges, positive and negative. When charges transfer from one body to the other, the bodies are said to be charged. The moving or flowing charges produce an electric current. An electric current consists of a movement of negative charges, that is, electrons. The flow of electrons gives us electricity. Electric current is measured by ammeter. Dry cell battery used in a torch or transistor radio is a source of electric current. Every battery has two terminals marked plus and minus. When a metallic wire connects these two terminals, the electrons resulted from chemical reaction start flowing through the wire, constituting an electric current. These electrons flow from the negative to positive terminal. Thus, a cell is a simple device in which chemical energy is changed into electric energy. Some materials allow electric current to pass through them, others do not. The materials that allow electric current to pass through them are called conductors. Iron, copper, brass, aluminium, silver, gold, graphite, etc. are the conductors of electricity. The materials through which electric current doesn't flow are called insulators. Insulators are also known as non-conductors of electricity. Paper, wood, plastic, cloth, eraser, rubber are the insulators. Pencil lead is made of graphite. It is a form of carbon. It is non-metal, but it is a conductor of electricity. It can be tested whether a given material is a conductor of electricity or not. The given material between the free ends of wires in an electric circuit face the given material between the free ends of wires in an electric circuit. Bring the free ends of the two wires close.
What we learned till now, it is clearly explained.
Now let them touch each other. If the bulb glows,
See, light
the material
charges the
is
bulb.
electrically conducting, otherwise it is an insulator. Both conductors and insulators are important while using electricity. The conductors like copper or other metallic wires are used for electric supply, but at the same time, these metallic wires are coated by insulating materials like plastic or rubber for safety. Summary.
Right. So
Let us
clearly-
summarize what we
Clearly explain whatever we want. Right. Whatever we want for today, what we learned so far is clearly explained here, starting from how electricity comes, the word comes and given by the Thales to up to conductors, semiconductors and insulators. Clear? So electricity is nothing but also one of the form of energy because we are doing some work with that. We cannot imagine our work without electricity nowadays. Correct? So if electricity is not there, we go opt for the generators, inverters, because there is that much emergency for us. Without that, we cannot live for fraction of seconds also. So such a wonderful form of energy which is discovered 2600 years back by a Greek philosopher, Thales, by simple rubbing the two objects. You can do at home also. Rub any two objects and observe how they get the charges. What happens when you are rubbing like this? The free electrons present in neutral bodies are transferred. Due to the transfer, both the bodies will get the opposite charges and they attract because unlike charges attracts each other. Then all the substances which are available with us, they cannot behave same in the electric field. Some of them allows the light to pass through them, which are called conductors. Some of them do not allow the light to pass through them, which are called insulators. Some of them partly allows the light to pass through them. They are called semiconductors. Okay, germanium, silicon, and all will come. Now come to next point. Before ending the sessions, one more point we'll discuss here about the very important electrification. The process by which body is electrified. What is electrified? Giving charge. Suppose if you take a pen. So pen is a neutral body because it contains equal number of positive and negative charges. I have taken another pen. It is also neutral body. But when both of them rub for some time, both will get the charges. So what we are doing? We are giving charge to a body. We are electrifying the body. Such a process of giving charge to a body is called electrification. The process of giving charge to a body. There are so many methods are there. The one Thales observed is only frictional electricity, by friction. So later there are so many came. From heat also you can produce electricity. From light also you can produce electricity. So many ways we can produce electricity. From garbage also you can produce electricity. Right? From cow dung also you can produce electricity. Different methods. But what happened in every case? We are giving charge to them. We are electrifying them. Such a process of giving charge or electrifying the body is called electrification. Okay. So what are the methods of electrification? There are so many methods are there. So from starting from Thales to the Ampere, a body can be charged by one of the methods such as friction, conduction, and induction. Right? There are 4 methods: conduction and induction. Induction means without direct touch. With contact, without direct contact, with rubbing each other. All these are the methods for converting the neutral body to charged body. That method is called electrification. Right? The method of giving or establishing charge to a neutral body. In a simple word, the process of electrifying a neutral body is called, it may be either by friction, it may be either by contact, it may be either without contact. Induction, that is called. Induction is without contact, we can convert. By placing 2 bodies away from each other, due to the transferring of charges around through air, other body will get charged. That you can do in experiments in the laboratory also. Such a wonderful method is called electrification. So, as I told, all the bodies are neutrally electrical because every body contains same number of electrons and protons. But when they are rubbed or when they are inducted, when they are in contact, they may transfer electrons from one body to another body, which results for electrification. Right? In the top priority is charging by friction. Right? First observation is made this only. Friction is nothing but rubbing only. Charging by rubbing. You can rub one body with another body and you can get both the bodies will attain. Just now we have seen in a video also. Umber and fur, cat skin, silk cloth, ebonite rod, silk cloth, glass rod, silk cloth. When you are rubbed them, what happens? Both the bodies are attaining charges because of friction. That is called frictional electrification. So many observed, not only 1 or 2. The scientists observed many objects were combined. And what they found is, when the 2 bodies are rubbed, they can attain the charges. They are electrified. They are electrified and attains the unlike charges. So like that, there are so many examples are there in this. So in next class, we'll discuss about what are the importance of this frictional electricity. Right? The frictional electricity, how we'll get that, we'll see. Then there is another explanation is there. What is conduction? What is induction? Means methods with them. First is friction, then is conduction, then is induction. By all these methods, you can convert the neutral body into charged body. Then law of electric force are there, where we come across the Coulomb's law. That is synopsis 2. In next class, we'll discuss about all these things. Okay. and lightning in the nature also, thunder, also because of electricity only. So sources of electricity, where we get the electricity, from where we can get the electricity, all these things comes under the source. So coming days, we'll discuss about all these things and right. So now this is today's work. What is electric current? You can define the charge. Due to the flow of electron, current, electric current will come. The charged bodies. When the charge flows from one body to another, we'll learn more about this electric current in the next classes. Exactly, mathematical formula also. So this is today's home task. And hope you all clear about this. So today we learn about what is electricity. That is first prehistory of electricity. What is electricity? What are the charge? What are the electric charge? Two types of charges, right? And electrification and methods of electrification in brief. So next class we'll continue. What is exactly the frictional electrification? What is the induction? What is the conduction? Then we'll go for the law of electricity, Coulomb's inverse square law. Clear? So that's all for today. Thank you all of you. Have a wonderful day. Thank you.